Hello everyone, this is the fourth episode on alcohol, phenols and ether. Today we are going to go how we are to discriminate or distinguish between the primary, secondary and tertiary alcohol. So there are n number of tests. Today I'll be showing you 4 different tests by which we can distinguish between the primary, secondary and tertiary alcohol. And here we go. So student, first one is through oxidation. So here this is the primary alcohol. Primary alcohol, when we oxidize, there are many number of oxidizing agents like P2O5, concentrated sulfuric acid. We can use KMNO4, we can use K2Cr2O7 in the presence of acid medium. So there are many kind of oxidizing agents. So you can give the oxidizing agent to turn the ethyl alcohol to acetaldehyde. So acetaldehyde, when you get acetaldehyde, you know that it shows tolerance test, it shows Fedding's test, it shows Schiff's test. So when we go for secondary propyl alcohol or secondary alcohols, so in secondary alcohols when we oxidize it, it is going to form ketones. And ketones, they will not show the Fedding's test, they are not going to show Schiff's test, and they are not going to show tolerance test. So the turbid or the like silver nitrate test for the tolerance test will not be shown by these ketones. Here also you can see that they are forming, the third degree alcohol also forms the ketone, but the number of the carbon atoms are less. So here you can see there are 1, 2, 3, 4, but here you get only 3 carbons. So here the number of carbons are same, but here the number of carbons are less than that of the reagent. Now, this is the way by which you can distinguish between the primary, secondary and the tertiary alcohol. But the main thing is that here it is that by the test you cannot distinguish between secondary and the tertiary alcohol because both of them forms ketone. Let us now switch on to the second part, that is with heated copper. So when we heat copper around 300 degrees centigrade or 573 Kelvin, it is going to form acetaldehyde or aldehyde. With secondary alcohol, it is going to form ketone, and on tertiary alcohol, it is going to form an alkene. This is how we can differentiate the primary, secondary and tertiary alcohol. On this primary alcohol, it forms acetaldehyde, and acetaldehyde can show you the test on tolerance. It can show positive test with Fedding solution, and it can also show positive test with the Schiff's reagent. It will turn the Schiff's reagent pink, and with Fedding solution it is going to form red precipitate of copper, and when you are treating with tolerance reagent, it forms a cloudy or milky appearance of silver nitrate, so silver chloride. So next is that when you are taking a secondary alcohol with copper at 573 degrees centigrade is going to form ketones, and ketones does not show any positive test with tolerance reagent, it does not show any positive test with Fedding solution, and it will not show any positive test with that of Fedding solution. Now here we have a very interesting thing here. This is the 3 degree alcohol or tertiary alcohol. So 3 degree alcohol, this is secondary alcohol or 2 degree alcohol, and this is primary alcohol. So in the tertiary alcohol, what we have is when we are treating copper at 300 degrees centigrade or 573 Kelvin, what it forms an alkene. And when it forms alkene, remember it is an unsaturated hydrocarbon, and being unsaturated, if you treat the red color bromine solution, it is going to turn colorless. And when you take pink color KMNO4 solution, it is also going to turn colorless. But they are not going to show any test for like this for the primary and the secondary alcohol. So 3 degree alcohol having unsaturated part would be showing you that positive test with the bromine solution and KMNO4 solution. Bromine, the red bromine color will turn colorless, and the pink color of KMNO4 also will turn colorless. This is how we distinguish between primary, secondary and tertiary alcohol. Now let us go for the third test. This is called Lukas test. And what is the Lukas reagent, student? This is hydrochloric acid and zinc chloride in the ratio 1:1. So what is Lukas reagent? If questions being answered, you have to say it is a mixture of hydrochloric acid and zinc chloride, anhydrous zinc chloride in the ratio 1:1 by mass. So when you are mixing the two and allow the mixture to pass through the primary alcohol, secondary alcohol and tertiary alcohol, you will see that there will be a white PPT or a cloudy appearance. You can see immediately if the PPT or the precipitate is obtained at once. The moment you are giving the Lukas reagent in the alcohol, if the white PPT or turbidity comes at once, so what will happen? This is a 3-degree alcohol or tertiary alcohol. But if it comes after 5 to 10 minutes, it is secondary alcohol. And if it comes, if it does not come any precipitate, even at the cold, but when you heat it, there is a white PPT forming, it is called as the primary alcohol. So student, here you will be learning about how to distinguish between the primary, secondary and tertiary alcohol. In case of the tertiary alcohol, there will be a PPT immediately the moment you give the Lukas reagent. For the secondary alcohol, 5 to 10 minutes after you give the Lukas reagent to the alcohol, if that the white PPT is formed after 5 to 10 minutes, it is called secondary alcohol. And if no PPT comes when it cold, it is called as primary alcohol. But remember, when you heat it, the white PPT may come up. Our next thing is about the Victor-Meyer's test. This is very important and very legitimate to go with this type of test in our labs. This is a primary alcohol. Primary alcohol in the presence of red phosphorus and iodine, what happens? It forms ethyl iodide or alkyl iodide. With AgNO2, silver nitride, it is going to have ethyl nitride. So ethyl nitride, when you treat with nitrous acid, HNO2. So HNO2 I have written in a different way, HONO. Actually it is HNO2. When you add HNO2, what happens is the hydrogen from here and the oxygen from here, they liberate out to form water. H2 and O goes away. So what is remaining, student? You will see CH3, a carbon, CH3, a carbon, and then you have NO2, and here you have NOH. You have your NOH. So carbon has got 4 bonds and nitrogen has got 3 bonds, 3 here, carbon 4, and it forms nitric acid. Nitric acid, how can you understand the presence of nitric acid? If you add here sodium hydroxide, it will give you a blood red color. You may think, yes, really it looks like blood. So it is a blood red color. When you add some few pinch or a little ounce of sodium hydroxide solution, you will see nitric acid showing you blood red color. So primary alcohol, first you treat with red phosphorus and iodine, followed by AgNO2, and then when you add nitrous acid, it is going to produce nitric acid, and nitric acid is understood by the presence of the blood red color when you add any kind of strong alkalis. Our next part is for the secondary alcohol. This is primary alcohol, 1 degree alcohol. This is 2 degree alcohol or the secondary alcohol. When we add red phosphorus and iodine and then followed by AgNO2 and HNO2 successively, we are going to get pseudonitrile. This is pseudonitrile. Similarly, here 1H and H and O. So this comes as water, HH, 2H and O. So what is remaining is NO. So here NO2 and NO. So CH3, CH3, here NO2 as usual, and here this NO comes and join with the carbocation, and this is forming pseudonitrile. How can you understand pseudonitrile? By the presence of the blue color with any kind of strong alkalis, whether NaOH or KOH. So student, I repeat once more, for the secondary alcohol, you add red phosphorus and iodine, a bit of heat, and followed by silver nitride with HNO2 or nitrous acid, you are going to get pseudonitrile, which can be understood by the presence of the blue color when you add any kind of strong alkalis with it. Our 3-degree alcohol, this is 3-degree alcohol. 3-degree alcohol, when we add red phosphorus and iodine is being added here with replacing the hydroxide path as usual, and then when you add silver nitride, you are going to add the replace iodine with the nitride path, and when you add HNO2 there will be no reaction. So the reaction stops and there will be no such kind of colors you can notice. This is how we can distinguish the primary, secondary and tertiary alcohol through Victor Meyer's method. So you students, these are the 4 ways by which you can distinguish the primary, secondary and tertiary alcohol, and hopefully you have understood it. And if there is problem, please let me know. Till then, have a nice time. Thank you.